Hello YouTube, welcome to my channel. In today's video on network analysis, I'm going to walk you through some examples to enhance our understanding on the concept that we discussed in our previous video. And that concept is the concept of charges, current, potential difference, and power. Now, before we kick off with our examples, we need some background knowledge on differentiation and integration. Now, like we know, differentiation involves us taking a function and trying to use that function to understand what happens to the most smallest part of that function. You can simply relate it with you trying to get a building, but you don't understand how the building is designed, and you really kind of reduce the building all the way down to the smallest particle, like using the whole to justify the little. The same thing happens to the integration. It's just the opposite of differentiation. What we are doing is we are taking the little to justify the whole. Now, forget about the whole grammar. The most important thing is, and if I have a function, let's say v, and it is equal to time, that's t to the power of n, that if I am trying to differentiate this function, the differential is defined as, I'm just going to take n multiplied by t and subtract it from 1. That is the basic definition of differentiation. So what I'm going to do is the v, the t, which is the derivative, is going to be n, which is n times 1, because there is a 1 here, t raised to the power of what? N minus 1. This is the basic definition of differentiation. Now, the same thing applies to integration. So if I have a function, the same thing, v equal to t to the power of n, and I want to integrate, the integration symbol goes like this, like an x. Now, the integral of v with respect to this is going to be, that is going to be t raised to the power of n. This time around, I'm going to add 1, and then I will divide all through by what I have as the power, which is n plus 1. So this is just the basic definition of differentiation and that of integration. Okay, now let's take some example. Let's say we have v defined as 3t squared. Now, what is the derivative of this guy with respect to time? So the v, the t of what I have here is going to be 2 times 3 is going to give me 6. T, to subtract 1, I'm just going to have 1 there. There's no point writing it as 6t to the power of 1. So you can simply write as 6t, and that is the answer. That is the derivative of v. Now, to prove that integration is just the opposite of differentiation, we are just going to take the integral of 6t. So when we take the integral of 6t, we say integral of 6t is going to be 6t. Remember, it's to the power of 1, so we just add it divided by the powers, which is just 1 plus 1. And that will be equal to 6t squared all over 2. You know that 2 can take care of 6 and 3 will be left. So the final answer is going to be 3t squared. Remember that this guy over here is the same thing as this guy over here. And that proves to you that differentiation and integration are just in opposite to each other. That's the background knowledge of differentiation and integration. Now let's proceed with our examples. Now the first problem, now that's the question. Question number 1 is, how much charge is represented by 4,600 electrons? Remember what I told you about electrons? I told you that charges, from the knowledge that we have on charge, we define that 1 electron is equivalent to 6.02 times 10 raised to the power of minus 19 coulomb of electricity. Remember, electron is negatively charged, so it's just going to be negative minus 606.02. So if you can remember this information, it simply implies that you can be able to solve this problem. It's a really simple problem. So if one electron is equivalent to minus 6.02 times 10 raised to the power minus 19, how much charge can 4,600 electron represent? So you can easily punch that out. So we can say that if one gives us this, definitely 4,600 electron will be 4,600 multiplied by minus 6.02 times 10 raised to the power of 19 coulomb. And when we punch that out, we will simply get, okay, that is, so that means that the charge, the quantity of charge will be, the quantity of charge will simply be 4,600 electrons, and the answer will be equal to 4,600 electron times 6.02 times 10 raised to the power of minus 19 coulombs. So if you punch that out on your calculator, you'll be able to get 2.7692 times 10 raised to the power minus 50 coulomb. And this is the charge, is negatively charged, is the charge that over 4,600 electron is going to give you. So that is problem number one. Okay, now the second problem says the total charge entering a terminal is given by Q equals 5t sine 4 pi t millicoulomb. Calculate the current at t equals 0.5 seconds. Feel free to pause the video to try to solve the problem yourself. Now let's solve this problem together. Remember what I told you about differentiation. Remember what I told you about current. Now we say that current is defined as the rate of change of charge. So as a matter of fact, the Q dt will give me current. So you remember what the Q dt no means? The Q dt, as we previously discussed, looks similar to something like this, dv dt, and that is differentiation. So it simply implies that if I differentiate the quantity of charge with respect to time, current, and that is what I'm asked to find. So the first step I'm going to do is I'm going to differentiate the charge with respect to time, and then we subtract of time 0.5 seconds, and boom, we got our answer. So let's do that. Remember, now there is something I want you to understand when it comes to this. So in the parameters, we have quantity of charge equals t sine 4 pi t. Now notice this. I can simply write this guy as Q equals 5t times sine 4 pi t. So what does that tell you? I'm having two functions, 5t and sine 4 pi t. And there is an area of differentiation that allows us to do justice to this very easily. And that area is what we call product. And product says if you have a function f of x be having two functions u, find v, this is a function u, and this is another function v. Okay, so in order to solve this problem, in order to differentiate this function, having two functions u and v, multiplying the order, that the f of x over the x is going to be, we take u, we differentiate v with respect to x, then we add it to v, then we differentiate u. So if we do these things, this will give us the differential of that. So we apply this thing to this guy here, we can see we'll have that dq over dt is equal to Now I'm going to take 5t, so I'll write 5t, and I will differentiate sine 4 pi t. Now if I differentiate sine, I'm going to have cosine. Now this product here is going to come over here because it's multiplying the time. So if I differentiate 4 pi t first, I'll have 4 pi. So 4 pi multiplying sine of this, we call it function of a function. So you just need to revisit differentiation for proper understanding of this. So we take 4 pi multiplied by sine this, we got this is 4 times the differential of sine 4 pi t is going to be 4 pi. Differentiate sine, you get cos and 4 pi t. And that is for this. We add it to what? We take this guy, which is sine 4 pi t, and we multiply it by the differential of 5t, like we did in the first video, like we did previously. 5t will simply going to be differentiated, you have 5, because the reason why you're going to have 5 is because if, like I said, if I like from that 60, if I differentiate this 60, is going to be, what is here is 1. 1 times 6 is going to give me 6 of t raised to the power of what? 1 minus 1, and that is 0. T to the power of 0 is going to be 1. Just be left with 6. So that's how we got that to be 5. So in that case, we simply have this. This is equal to the current. So our current, which is what we are looking for, is equal to the Q, the T, and that will be 5t times 4 pi cos 4 pi t plus sine 4 pi t multiplied by 5. So you can just bring that 5 here. So this is what we have, and that is current. Now we are asked to find this current at t equals 0.5 seconds. So in that case, we are just going to substitute the value of t equals 0.5 seconds into our values. So when we do that, our current, so just take it all the way down here. So current I is going to be 5, we put 0.5 there, times 4 pi cos 4 pi, we put 0.5 here, plus 5 sine 4 pi, put 0.5 there. Now we now punch that out on our calculator. So when I'm doing that, I'll have the current to be at 1.42 ampere. Remember, the unit was a millicoulomb, so definitely the unit of the current is going to be in milliampere, and that is the final answer for this current. So that is it for problem number 2. Now let's try out problem number 3. Now the question says, determine the total charge entering a terminal between t equals 1 second and t equals 2 seconds. If the current passing through the terminal is I equals 3t squared minus t ampere. Now feel free to pause the video and try the problem yourself. Okay, now let's get started. Now, what are we given? We were given current to be equivalent to be equal to 3t squared minus t. Now, we were given the interval or the range, which is from t equals 1 second to t equals 2 seconds. And what are we asked to find? We are asked to find the quantity of charge. Now, remember what I told you about current. Current is defined as the cube over the t, and like I said, this is the differential of quantity of charge. Now in this case, we are asked to find the quantity of charge. Now the quantity of charge is going to be I the t, that is the q, is going to be I dt. And what that means is that when I take the integral of both sides, if I get the integral of the cube, I will have cube, which is the quantity of charge. And that will be the integral of I the t. Now, that is what I told you. I told you that quantity of charge is simply the integral of current, whereas current is the differential of quantity of charge. So what we're going to do then is remember the interval. This integration is with a limit. So the limit is from t equals 1 seconds to t equals 2 seconds. So let's go ahead and solve this problem. So in that case, we'll say that the quantity of charge is equal to the integral from 1 to 2 of what? 3t squared minus t. Remember what I told you about integration. So let's go ahead and integrate this guy. As usual, we will have integrate 3t. You have 3t cubed over what? 3. Now minus it, we have t squared over 2. And the integral of these both is with the limit from 1 to 2. So let's quickly do that. Now this is the integral. Now the integral is from this limit. So what it means is that I'm going to substitute the value of 2 here in this equation and subtract it from this equation when the value of t is 1. So let's do that. We have that q is going to be 3. What is t? T is 2 cube over what? 3 minus what? T is what? 2 squared over 2. This whole thing minus, now when it is 1, we have 3 over 3 minus 1 2 over 2. So when I put this on my calculator, I will have the answer to be equal to 5.5 coulomb. Now that is it for this problem. And the next problem we are going to solve is going to be based on energy. So let's take the example number 4. Question says an energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. If 2.3 kilojoule is given off in the form of light and heat energy, calculate the voltage drop across the bulb. Feel free to pause the video and try out this problem yourself. Now let's put down the parameters. When the problem becomes a little bit complex, it's good to write down the parameters. So what we are asked, we are told that an energy source forces a current. So the current I is 2 ampere for 10 seconds. Time is 10 seconds. Now to flow through a light bulb. Now if 2 point, so the energy given off, that is energy or work or energy given off is what? 2.3 kilojoule. Now Earth in the form of light and heat energy. Calculate what the voltage drop across the bulb. So we are looking for the voltage. Now voltage is a quantity of charge. We say that voltage, which is the potential difference, is what? The work done in moving a unit charge of 1 coulomb from one point to another. So as a matter of fact, voltage is work over charge. But in this problem, we were not given charge, but we can get charge because we know that charge is equal to current per unit. Sorry, it's equal to current times time, because current is defined as quantity of charge per unit time. So it simply implies that if I'm looking for charge, Q is going to be current times time. So when I implement that, I will have that my quantity of charge was current given here is 2 ampere. So I have 2 ampere times time, 10 seconds, and that will be equal to 20 coulomb. So when I put this guy here and put work here, I will have that potential difference is going to be 2.3 kilojoule over 20 coulomb. And when that happens, 2.3 kilo is simply 2.3 thousand. So I will have 2,300 joules over 20. So this, take care of this. If I point that on the calculator, I will have it that 2,300 column of 2,300 joules over 20 columns, and that is 115 volt. So the potential difference that was dropped across the bulb is 115 volts. Alright guys, that's gonna do for this video. I will see you the next video for another wonderful episode on network